Welcome back. Today we're going to get into solving one-step equations. Now, I know for some of you, you have a fear of dealing with algebra. I want to take a moment to let you know, did you realize that you were doing algebra way back in the first grade? Let me refresh your memory just a little bit on how much algebra you've actually done in your time. Do you remember doing problems like this, where you would have a little square? And so if you take this square and you add 3 to it and you get 4, what goes inside that square? And you would think to yourself, oh, I know what it has to be. It has to be 1 because 1 plus 3 equals 4. Well, you know what? That is actually a form of algebra. You had your unknown, which is your square, and if you added it to the 3, which was your known, you would end up getting the 4. And so actually when you were in the first grade, second grade, whenever you would have first seen this, you have been doing a little bit of algebra. And we're going to take that a step further today. And instead of using a little square or an apple or a triangle or whatever you've used when you were younger, we're going to use a variable in the form of like a letter. And so you'll sometimes see variables as an N or an X or a P or all sorts of letters. And so they all just mean they are an unknown value. They're representing an unknown value, basically. And so the letter, it doesn't really matter when you're solving equations. Unless, of course, you're to substitute and they tell you values for certain letters. But for right now, we're not doing that. We're just solving equations. Um, Now, an equation, what is an equation? Well, basically, an equation, this is a statement saying that one expression is equal to another expression. And when you're doing this, you've got to keep both expressions equal the whole time. For example, if I have 3 plus 1 equals 4, as you can see, both sides here are equal to each other. However, if I subtract 1 from this side and these cancel out, now I'm left with 3. Is 3 equal to 4? Obviously, it's not. And so my question to you would then be, what would I have to do to the 4 to make the right-hand side of the equation equal? Well, if I have 3 on the left-hand side and 4 on the right-hand side, I'm going to have to subtract 1 from 4 and then make it 3. And now 3 is equal to 3, and our equation is still equal on both sides. Well, that is basically what we're doing when we solve equations. Our goal when we solve equations is to find the value of our missing variable, our unknown. And when trying to figure it out, we're going to move numbers from one side to the other. And whatever we do to one side, we have to do the other. So let's go ahead and try one just to see how it goes. Let's say we have y plus 4 equals 9. Now, for many of you, I understand you can look at this, you know the answer. However, think of this, these are your baby steps. You have to learn how to follow the proper steps in solving equations and start with the easy equations. So when you get to the more difficult equations, it's going to be much easier. You're not going to have to relearn all the steps because you were doing these in your head before. So let's just go ahead and we're going to follow our steps in here. If I have y plus 4 equals 9, I want to get y by itself. And the only way I can get y by itself is to get rid of that 4. And so to get rid of this 4, I'm going to have no choice but to subtract it. This is called an inverse operation. We're adding 4 in the equation. The inverse, or the opposite of adding 4, is to subtract 4. Now the thing is, whatever I do to one side of the equation, I have to do to the other side to make sure that both sides remain equal the whole time. And so when I subtract 4 from 4, they cancel out. When I subtract 4 from 9, I'm left with 5. And the wonderful thing with equations is you are able to check your answer to make sure it works. So I had y plus 4 equals 9. So if I do y plus 4 equals 9 and I plug in the value for y, which was 5, and now I do 5 plus 4 equals 9, I get 9 equals 9, and I know my answer is correct. Now, This is, I know, one extra step you have to do. But when you're wanting to make sure that your answer is correct and that you're doing it the right way, it's a minor sacrifice to make sure that you're doing things the right way. Let's try another one. For this one, let's go ahead and do one more of our addition problems. Let's have y plus 2 equals 8. Okay, so again, I want to get this y by itself. So the only way I can get the y by itself is to get rid of that 2. So since I'm adding 2, the inverse is to subtract 2. I have to subtract 2 from this side as well. They cancel out over here. 2 minus 2 is 0. Y plus 0 is y. 8 minus 2 is 6. So my answer is y equals 6. And again, I can check this by simply plugging it in. And I'm going to just jump ahead and say, well, for my y value, I'm going to put in the answer 6 plus 2 equals 8. 8 equals 8. I am correct. All right. Now that you're getting our addition ones correct with no problem, let's go ahead and move to a subtraction problem. It's the same idea. Let's say I have m minus 3 equals 6. Okay, so when we're looking at this problem, we have to think to ourselves. We have m minus 3. What is the opposite or the inverse of subtracting 3? Well, the opposite or inverse of subtracting 3 is to add 3. So if I have minus 3 plus 3, they cancel out. So over here, I'm also going to add 3. And so when I do this, I am left with m equals 9. And again, we can check this out by plugging in our value. We have our 9 value minus the 3 equals 6. Well, 9 minus 3 does equal 6. 6 equals 6. Therefore, I have a correct answer. Just that easy. We're going to try one more just to make sure you're getting this. I'm going to do, let's see, I'm going to pause this for 1 second. Okay, so let's go ahead and try one more of our subtraction problems. And when we do this one, I'm going to show you a slightly different modification on how to do this. And maybe it will make more sense to you. If not, you can do what we did on number 4. Let's say that we have n minus 2 equals 5. Now, one way you can do, if you remember back a while, we talked about LCO, leave change opposite. So if we put our LCO here, I can make this into n plus negative 2. And if I want to think to myself, what can I add to negative 2 that will turn it to 0? Well, I add the exact opposite of it. If I add a positive 2, we know that 2 negatives and 2 positives cancel each other out. And so in this case, these cancel out, and I'm left with n equals 7. Both ways work just the same. It's just, do you feel more comfortable dealing with addition on both accounts and then either getting rid of a negative number or getting rid of a positive, or do you prefer dealing with subtraction? It's completely up to you. I can solve it either way for myself. Sometimes I like working with the negatives just because that way I assign a value to my numbers and I can shift them around because addition is commutative. But that's just me. But again, we go back to our original problem, n minus 2. So I'm going to have 7 minus 2 equals 5. 7 minus 2 is 5 equals 5. And we have our correct answer. That is it. So hope this was helpful. You have a wonderful afternoon.